Hi class, today we'll be talking about section 4.7, transformations of quadratic graphs. We'll start with the standardized test practice, and this will be over using the quadratic formula. So what we have is the function h of t equals negative 16t squared plus 70t plus 6 models the height h in feet of an arrow shot into the air at time t in seconds. How long to the nearest tenth does it take for the arrow to hit the ground? So the ground would be at 0, so our quadratic equation would be set equal to 0 as it should be in standard form. Our A is negative 16, B is 70, C is 6. Again, to remind you, the quadratic formula is the opposite of B plus or minus the square root of B squared minus 4AC, all divided by 2A. So we'll take the opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So if we simplify under the square root, we're going to have negative 70 plus or minus the square root of 5,284 over negative 32. Now you can put this in the calculator, and that's what I would do, especially since they want our answer rounded to the nearest tenth of an inch. And I'll tell you what, you only want to do this with the plus. You don't want to use the minus, because that will give you a negative time, and that's not possible. So when you punch this into the calculator, you get that t is approximately 4.45 seconds, and so our answer would have to be B, about 4.5 seconds. So today when we transform graphs, what we're going to do is to write our quadratic equation in vertex form. This makes a function easier to graph. The form is this: y equals a parenthesis x minus h squared plus k, where hk is the vertex of the parabola, x equals h is the axis of symmetry and determines the shape and the direction the parabola opens. You can write a quadratic equation of the form y equals ax squared plus bx plus c in vertex form by completing the square. So that's what we're going to use to rewrite the standard form of a quadratic equation into the vertex form. This is going to involve a little extra step. So what we want to do first is we want to rewrite this as y equals 2x squared minus 12x plus a blank. Then you're going to write plus 25, so you're moving the 25 out of the parentheses, minus a blank. Notice that 2 is a common factor in here. So my next step is going to be to rewrite this as y equals 2 parenthesis x squared minus 6x plus a blank plus 25 minus, now since I factored out a 2, I have to do 2 times whatever the blank is. To figure out what goes in the blanks, we take the negative 6, we half it, and we square it. So that would equal negative 3 squared, which is 9. Okay, to write the perfect square in factored form, we would have y equals 2 times x minus 3 squared, and then we're going to write and simplify 25 minus 18, so this would be plus 7. This is the vertex form of the equation. 2 times x minus 3 squared plus 7. The vertex is at 3. Remember, you take the opposite sign here. 7. The axis of symmetry is x equals 3. And because our lead term, you can even see it right here, is positive, the direction of the opening is up. Okay, on B, start by rewriting this as y equals, in parentheses, do x squared minus 10x plus a blank. Outside of the parentheses, do plus 32 minus the blank. So to get the blank, we take the negative 10, we divide it by 2, and we square it. So that would equal negative 5 squared, which is 25. So we're going to add 25 and take away 25. And the reason that we're having to add and take away is because we're only working with one side of the equation. And to keep the equation in balance, usually what you do to one side, you do to the other. So since we're not touching the other side, we're going to have to add and subtract, and that keeps the equation still in balance. All right, so then we factor it, and I'll just go ahead and write it down here. We would have y equals x minus 5 squared. You can always get that number from right here. See over here, negative 3, it's half of the middle. And then we're going to take 32 minus 25, which would be plus 7. So our vertex will be at 5, 7. Our axis of symmetry is x equals 5. And again, since this is positive, you can see here, the direction of the opening is up. Okay, let's try a few more of these. On this one, our C value is 0. So when we work this, we will have y equals parenthesis x squared plus 6x plus a blank. Then outside of the parentheses, you can do plus 0 minus a blank, or you could just do minus the blank. You don't, yes, 0 will not change what we get. So then we take our 6, we divide it by 2, and we square it. So that would equal 3 squared, which is 9. Add a 9, subtract a 9, and factor. Y equals x plus the 3 squared minus 9. So our vertex is, and it's always the opposite, so it's at -3, -9. The axis of symmetry is x equals -3. And don't let this confuse you. Notice that this is positive, so the direction of the opening is still going to be up. Okay. On the next one, start off by writing it as y equals -4x squared plus 16x plus a blank, close your parenthesis, minus 11 minus the blank. Notice on this one, as in example A, that we've got a greatest common factor. We can factor out a -4 here. So let's do that next. We'll have y equals -4 times x squared minus 4x plus our blank minus 11, and then we're taking minus a -4 times our blank. So this is going to end up being plus 4 right here. So we're going to have half of -4 squared would be -2 squared, which equals 4. So we're going to put a 4 here and a 4 here. Now what we might want to do, we can go ahead and write the first part in factored form. Put our -4, we'll have x minus 2 squared. Then we have minus 11 plus 4 times 4. So we just want to simplify this. The -11 plus 16 should give us plus 5. So our vertex form would be y equals -4 times x minus 2 squared plus 5. Okay, the vertex, it's the opposite of h and then k, so it's 2, 5. The axis of symmetry is x equals 2. And this parabola, since it's negative out front, or less than 0, the direction of the opening would be down. So I'm hoping that you can see, if you're getting comfortable with completing the square, that these aren't too hard. You just have to remember that you do the opposite. Whatever you add on the inside of the parentheses, you take away on the outside. So let's try one more example. Okay, let's start with writing this as y equals, put in parentheses, 3x squared minus 12x plus a blank. On the outside, put plus 5 minus a blank. Notice that 3 is the greatest common factor inside of the parentheses, so we first want to factor that out. Y equals 3 times x squared minus 4x plus a blank plus 5 minus, okay, we can't forget the 3 right here. Since we're working, we factored it out, it's still part of this chunk. So we have minus 3 times our blank. To figure out the blank, we take negative 4, divide it by 2, and square it. That would equal negative 2 squared, which is 4. So we're going to add 4 here, take away 4 here after we multiply by 3. I think we can do this part in our head, so let's just go ahead and write it in vertex form. We would have y equals 3 times x minus 2 squared. Then we have 5 minus 12, so this would be minus 7. Our axis of symmetry would be 2, negative 7. I'm sorry, our vertex is 2, the opposite here, and negative 7. The axis of symmetry is x equals 2, and since a is greater than 0, or positive, the direction of the opening is up. Okay, I hope that those examples help you with 4.7 as you try the practice, and I also hope you have a great day, and I'll see you next time.